May 27th, Classwork, Algebra 1, number 3 is an application question for quadratic functions. Greg is in a car at the top of a roller coaster. The distance d of the car from the ground as the car descends, which means that it's moving downward, is determined by the equation d is equal to 144 minus 16 times t squared, where t would be the time in seconds that it takes for the car to travel down to each point on the ride. How many seconds would it take for Greg to reach the ground? What you have to realize is that the distance from the ground is going to be 0 when it reaches the ground, so we're looking for d equals 0. To show this algebraically, we're going to substitute 0 for d. 0 is equal to 144 minus 16t squared. And now our goal is to figure out t, the time in seconds that it takes for that to happen. Essentially, we want to get t alone or isolate it. First thing that we're going to do is take away 144 from both sides. Now we have negative 144 is equal to negative 16t squared. We're going to divide by that coefficient of negative 16. Negative 144 divided by negative 16 is going to be a 9, and that's equal to t squared. We're getting closer to getting t alone. Next step is to undo that square, and the inverse operation would be the square root. Square root of 9 is 3, and the square root of t squared would be t. Therefore, it takes 3 seconds for Greg to reach the ground. There's also a grid here to show this graphically. And the important thing to realize here is, first of all, to rewrite the equation, we have d is equal to 144 minus 16t squared. We could, of course, sketch this on our calculator. We can input our equation for y equals, and we don't have the t button for time, so we're just going to use x. We're going to trade out t for x and y for d. Y would represent the output, which is the distance, and x would represent the input, which is the time. So we're going to put 144 minus 16x squared, and then we're going to graph this. You're going to notice that that's not the best graph, and that's because we have to alter the window to have a better viewing range. To do this, we're going to hit window, and we want to consider what's our x min and what's our x max. Our x-axis is down here. The minimum is 0. We don't want to see any negative time. And the max is 4, so we can change this to be an x min of 0 and an x max of 4. Then you want to consider, what do you want to count by the x scale or interval? Each of these x boxes is representing 1/5, because 5 of them in is a 1 full second. This is 1/5 of a second, 2/5 of a second, 3/5 of a second, 4/5, and then 5/5, which is 1 full second. Therefore, I'm going to make my scale of x 1/5. I also have to consider my y min. I don't have a negative distance, so I'm going to start off with a y min of 0. And the highest on this grid that the y-axis goes is a max of 150. And then consider your scale here. 5 boxes in is 50 feet, so each of these would be 10 feet. So I'm going to have a y scale of 10. Now I can see a better graph when I change that window. Which makes sense. Time is increasing, right? And the height of the car that they're in, that Greg is in, on the roller coaster is dropping as it descends until it gets to the ground. Right here is the ground, and that would be, if you hover over here with your arrows, you can maneuver your arrows using the cursor buttons. And you'll notice that it's reaching the ground at about 3 seconds. If we want to recreate this on our grid, we could create a table of values where we have t is your time and d is the distance. And we're interested in the time that is given here. We're interested in 0 seconds, 1 second, 2 seconds, 3 seconds, and 4 seconds. And we can go ahead and use our calculator to find the corresponding distances because we already have the equation in here. Second graph. And then we're going to go to 0 seconds, 144 feet in the air. 1 second later, the car is at 128 feet in the air. 2 seconds later, it's at 80 feet in the air. 3 seconds later, it's at 0, which is the ground. When the distance from the ground is 0, it takes 3 seconds to get there, and then you have 4 seconds is negative 112 feet. We're going to neglect that because that's a negative distance and we're not interested in that. We're going to plot these points, 0, 144. 0, 140 would be 110, 120, 130, 140 would be here. So 144 is going to be a few up. Then I have 1, 128. Go to 1 second, go up to 120. 130, a little below the 130 mark, so I'm going to put my point right there. 2, 80, 2 seconds. Go to the 80 mark, 60, 70, 80. And then at 3 seconds, it should be at the x-intercept, or the x-axis. And we're not going to connect this with a straight line because this is a parabola. You're not going to see the full parabola, though. You're seeing half of it, essentially. The other half would be over here, which we're not going to see because we didn't look at the time being negative.